We can divide vaccines based on what they are made from. We find the following categories: vaccines which use the whole organism, vaccines made from only a part of the microbe, vaccines that need a pathogen's genetic material, and vaccines created with toxins produced by bacteria. Vaccines which use the whole organism use the whole virus, altered in order not to cause any risk to the patients. This alteration is done with different methods, subdivisions to this type of vaccine. The first method makes inactivated vaccines, in which the pathogen is grown in cultures and killed, making them unable to produce an illness. An example is the cholera vaccine. This vaccine has some side effects, in which we can find anaphylactic reaction to previous doses of the same vaccine, severe anaphylactic reaction to any of the components of the vaccine, and acute, moderate, or severe illness. The second one causes live attenuated vaccines. These vaccines contain a weakened or less harmful version of the virus and results in the strongest protection. An example would be the smallpox vaccine. The third method is fairly new. It consists of using a virus as a vector to produce protection. This is called viral vector vaccines. An example of the vaccines done with this method is the Ebola one. It causes fever, headache, fatigue, and pain at the injection site. The next type is those who use a certain part of the pathogen, also called subunit vaccines. They use a protein or antigen of the microorganism. They cause a very strong temporary immune response. An example is the vaccine against hepatitis B. Some of these are created using recombinant DNA technology, producing the so-called recombinant subunit vaccines. The pros and cons of this type of vaccine are that there is no risk of infection, so almost everybody can receive them, but the cellular response and immunological memory induction are poor, which causes that several doses are needed to ensure prolonged defense. Now we will talk about vaccines that use genetic material. They are called mRNA vaccines. They cause a normal immune response, but without ever getting infected by the virus or its parts. It's a very recent technology and it has been very researched thanks to the COVID-19 pandemic. We will get back to that in another episode. The most common side effects are pain and swelling at the injection site, tiredness, headache, muscle or joint pain, colds, and fever. A pro of this vaccine is that it is quicker and more reliable manufactured than traditional vaccines, while a con is that it is not really stable at high temperatures. The last type of vaccine we are going to talk about protects against the disease rather than the germ. They are called toxoid vaccines and use the toxins that trigger the target illness. The immune response is much more focused than in other vaccines. An example is the tetanus vaccine. The assessment of reactogenicity is complex, since adverse reactions are more difficult to attribute to each of its components. A pro is that unlike the mRNA vaccines, they are stable as they are less susceptible to changes in temperature. A con is that it might require more than one dose.